Okay. Now we come to the definition of equally likely event. What do you mean by equally likely events? What are the events here? H. If you are tossing a coin, what are the events here? H and T, right? What do you have any reason to believe if it is a fair coin? Do you have any reason to believe that there are more chances of getting a head than a tail? Do you have any reason to believe? Tell me, if you are
Mm,
tossing a
no,
coin,
sir.
do you have any reason to
Yes,
believe
sir.
that okay, fine, chances are that I'll get a head more than a tail? Is there any reason to for you to believe this? You say okay, 50-50,
No,
either
sir.
head or tail, right?
Yes, sir. 50-50.
That means these two
Yes,
are
sir.
equally likely. The probability of this is half and the probability of this is also half. That means these two events are
Yes, sir.
equally likely. Similarly, you can have n number of events that are equally likely. So that is what the classical definition of probability is. This was just a revision of what we have done. Next, what we have done is that the probability of, if A and B, for any two events, if you have A and B, then what is the probability of occurrence of any of the two events? A union B, right? If you remember, I had told you, right? A union B is what? Either A or B occurs. Union, remember, I
Yes,
told
sir.
you, is associated with or, right? You
Yes, sir.
can you can write this as P, A or B, right?
P of
And if
A or B. Yes, sir.
right now, if you remember, I had given you this formula, P A union B, addition theorem. If you remember, P A union B is equal
Yes,
to
sir.
probability of A plus probability of
Plus
B
probability of B.
minus probability of A intersection B. Now, what is A intersection B? A intersection B means probability of A and B occurring together, right? P A intersection B means probability of A and B occurring together. Now, if
Yes, sir.
A and B are mutually exclusive, if you remember, if A and B are mutually exclusive. Now, if, again, I repeat the definition of mutually exclusive. What is the definition of mutually exclusive? Can you tell me before I repeat?
Sir, the things which are not happen together.
They cannot happen together. If they cannot happen together, that means A and B must be a null set, because A
Yes,
and
sir.
B cannot happen together. So therefore, A intersection B must be a null set. That means probability of A intersection B must be equal to 0, because they cannot happen together. Understood? Remember, union stands for or, intersection stands for and. Clear?
Yes, sir. Yes, sir.
So PA intersection B must be equal to 0, because they cannot happen together. PA and probability of A and B occurring together must be 0, because they cannot happen together. It is an impossible event,
Yes,
right? A
yes, sir.
intersection B is an impossible event. So therefore, what can I write? If A and B are mutually exclusive, I can write PA union B is equal to PA plus PB only, because this part actually becomes 0.
Yes, sir.
Understood? So if A and B are
Yes, sir.
not mutually exclusive, then we will use this formula. If A and B are mutually exclusive, then we are going to use this formula. Understood? This is what we had done till your class 11. But the problem, with this formula is that PA union B, in order to calculate the probability of occurrence of A or B, you need the probability of A separately, right? You need the probability of B separately, and you need the probability of A intersection B also. That is A probability of A and B occurring together. What if you don't know this? Then how will you calculate? Understood what I'm trying to say? Suppose only the
Yes,
probability of occurrence of A and B are given to you,
yes, sir.
and the probability of simultaneous occurrence of A and B is not
Yes, sir.
given to you. Then how will you calculate the probability of occurrence of A or B? Okay. In this case, we use something called, now we are coming to your class 12 part. Okay. In this case, we use
Okay.
something called as the De Morgan's law. Okay. in your class 11, if you remember, under sets I had done De Morgan's law. Do you remember? Recall if you don't remember. But before De Morgan's law, let me just explain your independent events to you. Independent events. Okay. Independent events. From here, our class 12 starts. Independent events. Understood? Independent events. Now, what do you mean by independent events? Two or more events are called independent if the occurrence of one event does not depend on the occurrence of the other events. Two or more events. Please take the note of all this in your copies, because I am doing in a very, very systematic manner. If you don't take the note of all this, probability will get hodgepodged. Okay. In the approach to
Okay, sir.
probability, I would advise you to follow my approach. Okay, because the approach
Okay.
that I'm going to give you is a very systematic and very, very mathematical approach. If you can write all this in your copies as a note, just before the exam, if you go through, it will be sufficient for you. Okay, you don't have
Okay,
to
sir.
solve 10 problems from probability. Just do 5 problems and that will be it. Whatever problems that I'm going to discuss. So two or more events.
Sir, you will upload the video, no?
Yes, yes. Two or more
Okay,
events
sir.
are said to be independent if the probability of occurrence of one event does not depend on the occurrence of the other events. On the occurrence of the other events. What can be example of this? Suppose two coins are tossed separately. Separately and simultaneously, say. Two coins are tossed simultaneously. Suppose Amit tosses one coin and Govinda tosses another coin. Okay. Now, whatever the
Yes, sir.
result that Amir gets, whether head or tail, or whatever result Govinda gets, head or tail, whatever be the result, can you say that these two events are linked together? Or suppose Amir gets a head and Govinda also gets a head. Then can you say that because Amir got a head, Govinda also got a head?
No, sir.
You cannot. That means
No.
these two events are completely separate. You are tossing in your house, he is tossing in his house. There is no reason to believe that because Govinda got a tail, Amir got a head. Right? So that means if two coins are tossed simultaneously, both these events are independent. Both these events are independent. Right? Clear?
Yes, sir.
Two dice are thrown. Suppose three dice are
Yes,
thrown.
sir.
Why two? Suppose three dice are thrown. Three fair dice are thrown or are cast. Suppose one gets someone person one, first person gets a 2, second person gets a 3, third person gets a 6. Then can you say that person who gets a 3, because person 3 got a 6, that is why person 2 got a 3? You cannot say, right? So all these events must be independent. So
Yes.
all three events are independent, right? One does not depend on the other. Okay. From here comes the definition of independent event. Now let's see what the mathematical definition of independent events are. Okay. Mathematically, If two events, if A and B are two independent events, if A and B are two independent events, remember this definition, very important definition. Whenever two events are independent, then you can write PA intersection B, probability of occurrence of A and B together, will be equal to product of their individual probabilities, PA into PB. Clear? If A
Yes,
and
sir.
B are two independent events, then the probability of occurrence of A and B must be equal to the product of the probability of the individual probabilities of occurrence of events. Okay. In fact, why only two events? You can have n number of events. Okay. Extension. If E1, E2 up till En are n independent events, then probability of occurrence of all of them together, E1 intersection E2 intersection E3 up till intersection En, must be equal to PE1 into PE2 into PE3 and up till PEN. Is this property exactly clear? Very clear? Or any questions from this?
Mm,
No, sir, clear.
yes, sir.
Remember,
Clear.
I repeat once again, if A and B are two independent events, then the probability of occurrence of A and B together, that is A intersection B, will be equal to the product of the individual probabilities. Similarly, you can extend this notion to n events. That is, the probability of occurrence of n events together must be equal to probability product of the individual probabilities of the n events. That is what your basic definition, mathematical definition of independent. Now, what is the question? The question is, what if they are dependent events? Can you tell me what if they are dependent events? What if
Mm,
they are dependent?
Independent.
something which depends on other.
Yes, then if they are dependent event, then can I write this? No, we cannot write this. If A and B are, we'll discuss this later. That is, if A and B are dependent events, remember, later on we'll be discussing this in detail. If A and B are dependent events, then we use the concept of conditional probability. Then what will happen to PA intersection B? What is the probability of occurrence of A and B together? This time I will define the conditional probability later, but just know for the time being that if A and B are not independent events, that is, if A and B are dependent events, then you can write this as probability of A into probability of B, given that A has already occurred. Understood?
Sir, P of B by A.
Yes, this I
What
will
does it?
explain later. I will explain later this one. Okay. This one I'll explain later. This is called where PB slash A is called the conditional probability. Sorry, the conditional probability of occurrence of B, given that A has already occurred. Understood?
Yes, sir.
Given that A has already occurred. I will discuss this in detail. Don't worry. But for the time being, know that if they are not independent events, they must be dependent events. And what will happen to probabilities of dependent event? This is what is going to happen. A has already occurred. Clear? Or what you can also say is this is equal to, if you want to write in terms of B, suppose here what happens, A depends on B. Understood? What if B depends on A? Then what I'm going to do is I'm going to write this as PB into P A slash B. This time B depends on A. So we write where P A slash B is called the conditional probability of occurrence of A, because A comes first here, right? Given that given that uh, conditional probability of occurrence of um, oh sorry, this is con- uh, in the first one PB slash A, this is called the conditional probability of the occurrence of A, given that B has already occurred. Understood? PB slash A is, I will explain this once again, okay, but just remember that PB slash A means probability of occurrence of A given that B has already occurred. Similarly, PA slash B is the probability of occurrence of B given that A has already occurred. Now, why did I discuss this with you for the time for right now? I discussed this only to show you that there is a difference. There is something called independent events and there is something called dependent events. You
Dependent. Okay, sir.
okay? Right now, first of all, I'll only be discussing independent events. When I'll be discussing dependent event, then the question of conditional probability will come into play. Understood? For the time being, forget about conditional probability. Conditional probability is only applied when events are dependent on each other. Now your next question must be, so do you have a result for P if the E1, E2, En are n independent events? Then I can find E1, E2, E3 by multiplying the individual probabilities. In the case of conditional probability, what will happen if E1, E2, En are all dependent events? In this case also, we have a result, but that result is not required. Okay, remember, I will just mention this. We will not be doing this in detail, but I'll just mention this, touch upon this when I'll be doing conditional probability. For the time being, please remember that if two or more events are independent, then you can find the probability of occurrence of E1, E2, En all together by multiplying the individual probabilities. However, if they are dependent events, then we use the concept of conditional probability. Is that absolutely clear? The difference between independent and dependent events?
Yes, sir.
Remember one thing, just keep in your mind one thing, that dependent event means conditional probability. Understood? So till the events are independent, there is no question of conditional probability. Clear? So we
Okay.
will we
Okay,
will
sir.
not, right now we'll simply focus on independent events. Now, coming back to this concept, if you remember, I told you that PA union B is equal to PA plus PB minus PA intersection B. What if I don't know the occurrence of this? That is probability of occurrence of A and B together. Then what will happen? In this case, in order to discuss this case, I will first explain to you the De Morgan's law, first of all. Okay. I'll just, in fact, recap De Morgan's law for you. De Morgan's law. De Morgan's laws. In sets, we had done De Morgan's laws. In class 10 also, I think you have done De Morgan's laws, isn't it? In sets, in no, in your class 8, I think. De Morgan's laws. What is De Morgan's law? For any two events, for any two events, A and B, A union B whole complement. Remember from sets, A union B whole complement. I can write this as A complement intersection B complement. Do you remember this from sets? Now tell me. You remember this?
A complementing intersection complement. Yes, sir.
A union B whole complement will be equal to A complement intersection B complement. That is, if you are distributing the complements over A and B, then you have to change this union to intersection. See that the complement is only above A here. See that the complement is above B here only. And here, what is the complement? It is the complement is above entire A union B. Clear? This is De Morgan's law. There's one more
Yes,
law
sir.
from De Morgan, just the in fact the converse of this, that if I have A intersection B whole complement, and if I distribute the complement over A and B, I have distributed the complement over A and B, this intersection now will become a union. Is this absolutely clear? De Morgan's laws?
Yes, sir.
Yes, sir.
Okay, so once De Morgan's laws are clear, we now move on to some particular cases um, of application of De Morgan's laws in probability. Application of De Morgan's law in probability. Okay, application of De Morgan's law in probability. Uh, we'll discuss case by case. Okay. Uh, I think before discussing De Morgan's law, I'll just discuss a case of tomorrow. I'll do De Morgan application of this thing. I will do this tomorrow. For the time being, let us focus
Okay,
on
sir.
independent events. Let me just give you one more problem from independent events, and then I'll discuss continue this tomorrow. One problem. Now, here the problem here is that I will have to write the entire problem for you. There is no other way. Otherwise, you will not understand. Okay. Just from reading from the textbook will be impossible in the screen. So I will have to write the entire problem for you. Okay. So let's see this problem.
Okay, sir.
A fair coin, is tossed 3 times. It's tossed thrice. Let A, B, and C be defined as follows. Be defined as follows. A, what is event A? First toss is heads. This is the event, okay? A is the event that the first toss is heads. B is the event, this is all given to you. B is the event, second toss is heads. C is the event here that exactly two heads are tossed in a row. So 3 events given to you. What is the question? The question is, check whether number 1, A and B are independent. Second question is, B and C are independent. And the third question is, C and A are independent. And the fourth question is, A, B, and C are independent. Okay, so you have 4 parts to this question. So you need to check whether A and B are independent. Whether second question is whether B and C are independent. Third question is whether C and A are independent. And the fourth question is whether A, B, and C all are independent. Solution of this. Let us see first the events. So a fair coin is tossed thrice. So what should be a sample space? Here sample space is what? Sample space.
6 to the power 3.
You can get 3 heads. 3 coins tossed. All 3 heads you can get.
Oh, sorry.
Or you can get
Yes, sir.
2 heads and then a tail. Or you can get head, tail, and a head. Or you can get head, tail, and tail. Or you can get tail, head, and head. Right? Or you can get tail, head, and tail. Or you can get tail, tail, head. Or you can get all 3 tails. Right? This is a sample space. No other possibility. Any other possibility?
Yes, sir.
What possibility? Tell me.
Sir. No, sir. No.
No possibility.
No other possibility.
Now let's see what is the event A. The event A here is first toss is heads. That means first toss that your first coin that you're tossing, you'll get heads. This is one event. So H H H. This one is also you're getting first head. So H H T. This one also. So H T H, because all you are getting first heads, right? This one also H T T. Not this one. Not this one, because first one is a tail. Not this one. Not this one. Right? So A you have got.
Yes, only.
Right? What about B?
Yes, sir.
What is the event B? The event B here is second toss is heads. Second toss is heads. Now second toss is head. Which one? Which one? This one second toss is heads. So H H H is there.
Yes, sir. HST.
This one also H H T.
THH.
This one is not there. This one is not there. This one is there. T H H.
NT.
This one is there. T H T.
Yes, sir.
This one is not there, and this one is not there. Right? So this is the event B. What about event C? Exactly 2 heads are tossed in a row. Now let's see what exactly 2 heads are tossed in a row means. Two heads in a row means what? 2 consecutive heads actually. In this you are getting 2 consecutive heads, right? So HHH will be there. Where else you are getting 2 consecutive? Here also you are getting 2 consecutive head. First and second is a head. So HHT. Third one, here are you getting 2 consecutive heads? No. So this is out. Here are you getting 2 consecutive heads? No. So this is also out. Are you getting 2 consecutive heads here? Yes, you are getting in the second and third one. THH. This one, THT. No, not possible. This one, not possible. This one also not possible. So you got C also. Right? Right? Now
Yes,
we
sir.
shall see. First one, you need to show that A and B are independent. Now, if A and B are independent event, then A intersection P A intersection B must be equal to. Um, let us first calculate the individual probabilities. So, therefore, what is before attempting one? Let us see what is PA. So here PA is how much? How many events here in the sample space? You have 8 events, right? So this is 8,
8.
and in the numerator you have 4. So 4 by 8. So this is half.
Oh, yes. Half.
And here for PB again you have 4 by 8,
Here.
right? Which is again half. And for what is the probability of the event C? It is 3 by 8, right? So PA is half, PB is half, PC is 3 by 8, right? Now what happens? If we need to check whether A and B are independent, A intersection B. What is the event A intersection B? Check the events A and B. What are the events A and B? A is first toss is heads, second toss is heads. So what is A intersection B? First toss is heads and second toss is heads. So first toss is heads, and because there is an intersection, and second toss is heads. Okay, and what are the events here? First toss and second toss heads. This one. So H. This one HHT. The second one also. Right. Third one is not possible because here you have HT. Fourth one not possible because again you have HT. This one is also not possible because you have TH. TH not possible. TT not possible. Not possible. Right. So only these two you have. Right. Understood or not? Say fast.
Understood.
A intersection B is the event that first toss is head, second toss is head. So I have listed the events. So therefore, what should be PA intersection B? PA intersection B. How many events are there in A intersection B? 2. So 2 by 8, which is 1/4.
Yes, sir.
Right. Now, if A and B are independent events, you need to check, right? If A and B are independent events, then PA intersection B must be equal to PA into PB, isn't it? If PA intersection B is not equal to PA into PB, then what do we say? Can you tell me?
So not dependent.
Not independent. Not
Not
independent. Right. So
not
here,
independent.
what is PA
Okay.
intersection B? Here LHS is how much? PA intersection B. Right. I'm talking about this part. This part is PA intersection B, which
Okay.
is 1/4. And what is the RHS?
Yes, sir.
PA into PB.
RHS 1 by 2. Yes,
PA
sir.
into
Equal.
PB. That means half into half,
1/4.
which is 1/4. That means LHS is equal to RHS. Thus,
Yes, sir.
PA intersection B is equal to PA into PB is equal to 1/4. That means, hence, A and B are independent events. Understood?
Yes, sir.
Okay, so I stop here for today. Okay, it's been too much for today.